So this is the 2021 Leaving Cert Higher Level Maths Paper 2. So question 1 is on probability. So for part A, you're just going to be using that Bernoulli trial formula. So it's in your log table. So it's n choose r, and then it's p to the power of r, and q to the power of n minus r. So p is the favorable, the probability of favorable outcomes. So favorable outcome. And then the q is non-favorable outcomes. So the probability of p and the probability of q should add up to 0 in the end. And n then, n is the kind of the total. So here there's 11 players altogether, so 11 will be the total. And r is the amount that you're choosing. So in this case, it's find the probability that there is exactly one left-footed player. So therefore it'll be, you're only choosing one player, so it'll be 1. So r will be 1 in this one. So it'll be 11, choose 1. And then the probability of, okay, so what do we really want here? You're trying to find the probability that there is exactly one left-footed player. So that there is exactly one left-footed player, that's 15% or 0.15. And then r is again is 1. And then the probability then of q, so if the probability of a left-footed player is 0.15, well then the rest then has to be 0.85. So this is really the probability of them being a right-footed player. Yeah, that's 0.85. And then we do n minus r, so 11 minus 1 is 10. So that's all you have to do for part A, and you can just use the calculator then. It's just filling in that formula. Now they want the answer to 3 decimal places, so you can give 0.325. So that's when you put all that into the calculator and round it off. So that's the answer to the first part. Second part then, you're using the same percentages and all that then. It's just, so find the probability that less than 3 players on the team are left-footed. So less than 3 players, so that would have to be either 0 players are left-footed, one player is left-footed, or 2 players are left-footed. So that would include all of these. So 0, 1 or 2. So it says less than, so 3 players. So you can't include 3 players in it. So it's going to be similar enough to the part A. You're going to use the same formula again, but you're just going to use it for each of the 3 of them. So for 0 players, for 1 player, and for 2 players to be left-footed. So that's all you're going to do. So it's the same formula again. It's n choose r, p to the power of r, and q to the power of n minus r. So for 0 players, it would be 11. Well, it's choosing 0. Sorry, 11, isn't it? And then it's going to be the same thing. Then it's going to be 0.15 for, because it's still we want for left-footed players, and that's to the power of 0. And then it's 0.85 to the power of 11. So that's for 0 players. For 1 player, it's just changing the r really to be 1, and at this time we're choosing 1 player. Now you've actually already done that in the first part, so you could just put in 11. We're going to be adding them all together. You could just put in 0.325 I think here, because you've already done this, but this is how you do it again anyway. And then we're going to add on for 2 players as well. So then you can put all that in the calculator together if you want, or maybe the best thing is to work out each of them and add them all together. But at the end they want the answer to 2 decimal places, so when you put all that in and add them all together, you'll get 0.78. So that's the probability then that less than 3 players on the team are left-footed. Right, so for part C then, the goalkeeper is left-footed, so we already know that, so we're finding out the probability then for the other 10, so n will just be 10 here, so it's a kind of like one of them is kind of discounted here, we already know what it is, so there's no probability to work out. So that at least 8 of the remainder of the team are right-footed. So they want us to find the probability that at least 8 of the remainder is 10. So that at least 8 of the 10. So therefore at least 8 of the 10 would include 8 of the 10. It would include 9 of the 10. Or it would include 10 of the 10. So these are all included in at least 8. So at least 8 would include 8, 9 or 10. So it's very similar to part B actually, we're just going to work it out for this. Now this time it's for right-footed. So right-footed is the favourable outcome here. So remember at the start we said P is the favourable, so when you're putting P into the formula, it's P is the favourable outcome. So in this case our favourable outcome is that they're right-footed. That's what we're working out really, that's what we want. So we're going to let the probability of them being right-footed is 0.85, so P will be 0.85 and Q will be the other one, it's 0.15. So we know what N is, we know what P is, and we know what Q is, and the R will just be the 8, the 9 and the 10. So we have to do the same thing again. So 8, we'll just put that little heading in there. So 8 of 10 would be 10, choose 8. 0.85 to the power of well, it's R, so it's going to be 8, and 0.15 to the power of n minus R, which would be 10 minus 8, which is 2. So that's for 8 of the 10. For 9 of the 10, it would be 10 choose 9, 0.85 to the power of 9 times 0.15 to the power of 10 minus 9 is 1. And then for the other bit, the 10 of the 10, it's going to be 10 choose 10, 0.85 to the power of 10 10, and then 0.15 to the power of 10 minus 10 is 0. So we're just going to add all of those together then. So you can work each of them out separately and then add them all together, or you might be able to put it all in the calculator in one go. You could try if you want. Yeah, so I'm looking, so when when you do all that, you should get 0.82. Yeah, they wanted the 2 decimal places again, so 0.82. And then that's it. So it's all that Bernoulli trial probability formula for for question 1. So that's all of the question then.